Hello everyone. I wanted to bring you another example in recursion, a classic one, a towers of Hanoi puzzle, right? So this is one of a uh, interview questions, possibly when we learn recursion, and it is a pretty interesting problem. I just wanted to bring this up as we have almost completed recursion. So let's go over this puzzle. So the towers of Hanoi is a mathematical puzzle that consists of three rods, pegs or towers. I will show an online demonstration for the same, but I'll read out the problem statement here and a number of discs of different sizes which can slide onto any rod. The puzzle starts with the discs on one rod in ascending order of size, the smallest at the top, thus making a conical shape. The objective of the puzzle is to move the entire stack to another rod satisfying the following rules. Only one disk may be moved at a time. Each move consists of taking the upper disk from one of the rods and sliding it onto another rod. On top of the another disk that may already be present on that rod. No disk may be placed on top of a smaller disk. Okay, so there are three conditions. We can only move one disk, and each move consists of taking upper disk from one of the rods and sliding it onto another rod on top of another disk that may already present on that rod. No disk may be placed on top of a smaller disk, right? It should always follow a conical shape, or the smallest one should always sit on top of a larger one, right? So the I have even written down the algorithm, but before even looking at the algorithmic solution, we shall go to a Chrome browser, where I show you a demonstration of how this puzzle will be solved. Let's take uh, three disks, as this would be the easiest thing to think about. So I will just start playing this to show you how this puzzle is solved, right? So here, all of these three disks which are in the peg or tower A needs to be moved to tower C, and I will show you how it is done. So, and finally this one. So this way, all the three disks are moved from tower A to tower C. Like, firstly, we moved the top one from A to C, and I will reset. So I'll move in steps. Firstly, we move the topmost disk from A to C, and next we move the second most n minus 1 from A to B, and again we move the disk which was placed at C back to B, and then we move the final disk, which is the third disk that we want to move to the destination rod, the third disk to the C, and then finally we move the top disk to the rod A, and then we move the second most disk to C, and then finally this top disk comes over here. So I'll play this out. Let's see this in action. Yeah, so the third one moves here, and this one goes here, and again this one comes here. This goes there, this goes there. This solves the problem. So I have an algorithm here. So this is the simple algorithm that with recursion it is solved here. So if you see, I will just run this for a 3 disk. So the parameters here is n stands for number of disks, and from tower A to tower C with auxiliary rod being B, right? So I'll show this out. So firstly, you see these steps. Move disk 1 from A to C, and disk 2 from A to B, and disk 1 back from C to B, which is the auxiliary rod, and the final disk or the largest disk, which was in rod A to C, and the w- disk 1, which was the smallest one, from B to A, and the second smallest or the middle disk from B to C, and finally the first smallest disk, which is the final move A to C, right? This completes the move. So let's, just for curiosity, I'll even uh, play this same for a 4 disk solution, so you can see this. Yeah. So okay, so let's move to the JS bin to see how our recursive function performs, or what steps or what actions are, what moves are to be done, right? So I will change the number of disks to 4 from 3, and the starting rod will be A, and the destination rod will be C, while the B will be the auxiliary rod. And yeah, let me clear and let me run this. So as you can see, these were the set of things that we even saw in this animation here in this browser. And if you see, the number of moves is 15. Here also we would almost have 15 moves if we count it right. So this should also tell us the time complexity or the number of steps that are being taken to complete, based on the input of 4 disks, will be 2 power n minus 1. Like that is, let's say if we have 3 moves, it would be 7, and if we have 4 moves, then it would be 15, as we see here, right? Okay, so let me go back to the algorithm that we had, or the algorithmic steps that we need to perform to come to this solution. So whenever we had 3 disks, we it was pretty much easy for us to break down or understand. So the only thing that we need to understand here is, let's say we want to move the third disk to a destination rod, we might want to place all the n minus 1 rod, n minus 1 disk to the auxiliary rod, and thereby we can move the n minus 1 disks which are placed on the auxiliary rod to the destination rod. And so that's the whole idea. While we transferring the top n minus 1 disk from source to auxiliary, we can again have a fresh problem and can be solved in the same manner. So we break down a smaller problem, and also we can think about how each step or each move can be subdivided when solving a bigger problem, right? These are the steps that we need to perform, and I will go back to the JS bin where we have the algorithm written. So as you can see, we have n minus 1 disk to move to auxiliary rod, and similarly we are having to console log and also move them, and also we have n minus 1 disk from auxiliary to target rod, right? So yeah, uh, this is a pretty interesting problem, but I want you to think, or uh, wrap your brain around how we solve this problem. Hope you found this video helpful. Please do like and subscribe to my channel. Thank you.